Okay. So, yes, sir.
Who has the refill? Did you ever get a refill?
I do. It's sitting on the floor back here.
Oh, you're still good.
Yeah, I have got lots of stuff.
Yeah, you can buy them.
All right. Thanks, man. Yeah. Well, all tests are out of 100, so they're just the percentage numbers, what goes in the grade book, so everything is out of 100. All tests are equally weighted. Okay. So, chapter 2, we're going to be talking about absolute value functions. And we probably have some sense of what an absolute value function is from our previous algebra course, right? If I were to ask you, what does the absolute value do, what would you say? Evan? Just makes a number positive, right? So for example, the absolute value of -3 is +3. Or the absolute value of +3 is also +3. Everybody okay with that idea? So to give it a more formal definition, there's a couple of different ways we could define this, and we're going to define this a couple of different ways, just depending on the context in which we're working, may be more or less useful, depending on what it is that we're trying to do. So the absolute value of x is really the distance from x to 0 on the number line. So for example, if we're talking about the absolute value of -3, the distance from -3 to 0 on the number line is 3, right? Since it's a distance that we're talking about, that number is always positive. Everybody's okay with that idea? The other two definitions are algebraic definitions. So another definition for the absolute value of x could be the square root of x squared. Remember, if we take a number and we square it, we're guaranteed to get a positive number, right? Because positive times positive is positive. And negative times negative is also positive. So we can definitely take the square root of that. And the result from taking the square root is also always a positive number, right? So we're guaranteed to get a positive result. And we know that squaring and square rooting cancel each other out, so it's essentially doing nothing other than removing a negative sign if there happened to be one. So for example, if we did the absolute value of -3, and we use this definition, we're also going to get 3, right? Everybody's okay there? The third way that we might define this is also an algebraic way, but it's using what's called a piecewise function. So in a piecewise function, we're going to define the function with a different equation for a specific part of its domain. So for example, in an absolute value function, if we have a non-negative number, well, that's just going to stay the same. If we have a negative number, we're going to negate it, because the negative of a negative gives us back a positive. So for example, if we have the absolute value of -3, here the x is negative, so we're operating on this line. So we're going to do the negative of that number 3 to get us 3. As opposed to if we take the absolute value of +3, since 3 is greater than or equal to 0, we're going to do this line, which just is 3. Is that okay with everybody? To just kind of think about what we mean for a definition of an absolute value. Now, from a working standpoint, just knowing that it's going to get rid of negative signs and make everything positive is fine, right? Like that's a pretty practical definition. But if we're going to like construct a system and like talk about like how to think about this as a function and graphing in this function and all these sorts of tasks, we're probably going to want to have one of these more rigorous definitions to use to justify some of the things that we'll do. Okay with that? Okay. So in general, most of the time that we introduce one of these new functions, we'll talk about kind of how that function is going to work, like we've done here, its definition. We'll spend talking about how to simplify an expression involving that function. We'll talk about solving equations involving that function. And we'll talk about graphing. And probably also talk about modeling. So if I have a graph, how do I get back to the equation? So those are kind of the 4 things that we talk about every time we're going to talk about a new function group, because those are like pretty 4 fundamental skills in a high school algebra course. So again, we're talking about simplifying, solving, graphing, and then modeling are kind of the 4 skills that we'll spend some time, almost every chapter, doing each of these. Okay, so let's spend a few minutes here talking about how this absolute value function works, or the absolute value operation, how it works, and what are some things that we can do or we can't do. Okay, so I'm going to put something down that says like something is equal to something else with a question mark over top, and we're going to try to decide whether this thing that I've done is okay, if it's true, or if it's not true. If these 2 things are actually equal or they're not always equal. Okay? Let's use, okay. So I have the product of 2 things. Actually, let's use x and y. That probably makes more sense in this k and x business, right? That probably feels a little more natural to you guys, a little bit more familiar. So I have the absolute value of a product is equal to the product of the absolute values. And we'll put a question mark over that because we're going to discuss whether this is true always, true never, true sometimes. So if you're going to try to make a decision about whether this works sometimes, always, or never, what might you want to do to start? Yeah. Let's pick some numbers and fill in the blanks and see if it works, right? Okay. So let's pick a value for x. Somebody just yell one out. There's probably not a 17. Great. And let's pick a value for y. 1. Okay. So 17 times 1. And we're going to see if that's equal to the absolute value of 17 times the absolute value of 1. Well, 17 times 1 is 17. The absolute value of 17 is 17. The absolute value of 1 is 1. The absolute value of 17 is 17. And 17 times 1 is 1. So it works at least sometimes, right? Now, Anthony, what did you say? What if it's negative? Which one?
Either one.
Either one. So let's just pick x to be negative 17. And we'll pick y to be positive 1. Let's see if it works then, right? So we know it at least works sometimes, because when they're both positive, it seems like it works. And there's probably no reason to believe that any two positive numbers, you're not going to run into a problem. But we know the absolute value does something to the negative, so let's try that. So negative 17 times positive 1, is that equal to absolute value of negative 17 times absolute value of 1? Well, negative 17 times 1 is negative 17. The absolute value of 17 is 17. The absolute value of 1 is 1. The absolute value of 17 is, or negative 17 is 17. And 17 times 1 is 17. Yes. So at this point, we've probably convinced ourselves that this is always going to work, right? If they're both negative, is it going to be any issue? No, because you have negative times negative gives you a positive, and the absolute value of two negatives gives you two positives, so it's going to work, right? Is everybody okay there? Okay, so this is always true. Now, what we did right here, is this a proof? This is not a proof. We've just shown that it works in general in two situations. To prove it, we'd have to show it always works. We're not really interested in doing that right now. But what we've done is convinced ourselves that it's always true. We haven't yet proven it's always true. Is everybody okay with the difference there? Right now, we'll settle for convincing ourselves. And this is a nice step towards, if I'm going to try to prove this, I need to know what I'm trying to prove, right? Am I trying to prove sometimes, always, or never? Here we've convinced ourselves that it should be always. Proving that is a different story. In general, if you're going to try to prove something is always true, the easiest way to do this is by contradiction. Do you remember in geometry doing proof by contradiction? Would have been kind of brief. But the idea here was we'd assume that this doesn't work. And what would that mean? And from there, you can get a contradiction pretty easily. So if they're not equal, either one has to be greater than the other, which means that, like either one of them's negative, or the product of the same two things gives you a different number somehow, which we know is not possible. But I'm not interested in trying to prove this right now. It's a little bit more than I would expect for the scope of this class. Let's look at a second one. Oops. How about this one? Just at first glance, what's your initial instinct tell you without even thinking much too hard about it? You think it's going to work. That's kind of would be the natural thing. Let's try picking some values for x and y, though. You don't want to pick values for x and y? Let's do it anyways. What's a value for x? 4. What's a value for y? -2. So 4 plus -2 is 2. And absolute value of 4 is 4. Absolute value of -2 is 2. And we have that they are not equal in this case. So we've eliminated the possibility of this always being true. Is this ever true? Yeah, if you have two positives, or really just two non-negatives, because 0 would be fine also, this would work. So this would be like something that sometimes. But it's the uninteresting case. Where we have two non-negatives, where the absolute value is really not doing anything, right? Everybody okay there? Yes. What if they're both negative? Still won't. Oh, yeah, it would work. Right? Thank you. And really, let's say again, instead of negative, I'm going to use non-positive because 0 is certainly okay. So yeah, they have to be the same. Or both, or one of them 0. Right. You can't have a negative and a positive. That's what it comes down to. Thank you. Yes, you're absolutely right there, Mia. Two negatives would also get the same thing happening. Good thought. Okay? How about this? What do you think? We think sometimes it's a pretty narrow sometimes, but sure. Let's pick two values. Somebody an X? 16. Somebody a Y? -5. Okay. Oops. Got to write the question mark. 16 minus a -5 is 21. So that's 16 plus -5 is 21 equals 21. So there it worked. Okay. Well, is there a situation where it won't work? If they're both positive, so you say 16 and 5 maybe. So I get 11 is equal to 21, right? That doesn't work. So sometimes we're going to need a non-negative and a non-positive. If they're both 0, it's going to be fine. Or if one of them is 0, it's going to be fine. Okay? No new homework. So the last thing that, if you guys just need to finish up anything that you didn't check in yet. So like I think did we check the test review in the last homework check? I don't even remember. We did? Then you guys have nothing. Right? If I did the test review already. Sometime next week.